In this lesson, we will answer the question of how do you multiply polynomials. Well, before we do so, we need to recall the distributive property. Let's say that we wanted to multiply in our head the number 17 times 11. That's pretty difficult, right? Right away you probably think I need a pen and paper. However, if I write 11 as 10 plus 1, as I've done here, okay, this becomes a relatively simple problem because if I distribute the 17 inside to the 10 and the 1, I get 17 times 10, which is really simple, is 170, plus 17 times 1, which is 17. And then I just add these two numbers together, which is relatively easy to do in my head, and I get 187. I could do the same thing with this problem here, 3 times 29. That's difficult to do in your head once again, but if you rewrite it in an equivalent form of 3 times 30 minus 1, I could use the distributive property once again. Distributing the 3 inside, I get 3 times 30 minus 3 times 1. Well, 3 times 30 is easy, that's 90, minus 3 times 1, that's easy, that's 3. So I get 90 minus 3, which is 87. A few definitions here before we begin with the lesson. A monomial is a number, a variable, or the product of a number and one or more variables raised to whole number powers. For example, these are all monomials: 5x, negative 8y, and 3x squared times y to the fourth. A polynomial is just one monomial or a sum of monomials, which we've seen before. Each monomial in the expression we call a term. A polynomial with 2 terms is called a binomial. A polynomial with 3 terms is called a trinomial. You can multiply 2 binomials together using the distributive property, which we'll see next. Okay, so suppose I wanted to multiply these 2 binomials together. I can do so using the distributive property. Now, if I distribute this entire binomial x plus 3 inside, okay, to the 2x, I'm going to end up getting x plus 3 times 2x, shown here. Okay, so here's x plus 3 times 2x, and I do the exact same thing, x plus 3 times 1. So I basically take this entire term here the entire binomial again, and distribute it inside to the 1, which will ultimately result in this 1 times x plus 3. So I'm distributing the entire binomial inside to each of the terms in this binomial here. Right. After I've done that, I distribute once again, because notice I have 2x on the outside of these parentheses. I can distribute the 2x inside, which gives me 2x times x, plus 2x times 3. Distributing this inside once again gives me this term here. Doing the same thing with the 1, I get 1 times x plus 1 times 3. Then I just simplify. I can write 2 times x simply as 2x squared. I can write 2x times 3 as 6x, 1 times x as x, plus 1 times 3, which is just 3. Okay, so I only have one more step left to do, which is to combine like terms. 6x plus x is 7x. So in the end, I get that 2x plus 1 times the other binomial x plus 3 is just 2x squared plus 7x plus 3. Another example here, multiplying these 2 binomials. Notice I have subtraction here this time. However, it's not going to change very much. I'm going to distribute this 3x plus 6 into both terms inside the first binomial, so I'll end up getting 3x plus 6 times 4x, represented here, and 3x plus 6, except for this time I need to take into account the subtraction sign. So I actually have 3x plus 6 times negative 7, which will result in this here. Once again, I distribute the 4x inside to the 3x, which gives me 4x times 3x is 12x squared. 4x times 6 is 24x. Distributing a negative 7 inside, very important, the negative 7. Distributing it inside to the 3x, I get negative 7 times 3x, which is negative 21x. And negative 7 times positive 6, which is negative 42. Once again, combining my like terms, I have 12x squared. Since there's no other x squared terms in this polynomial, I pretty much leave it alone, and I have 24x, take away 21x, that leaves me with 3x and minus 42. So the product of these 2 binomials is this new trinomial, 12x squared plus 3x minus 42. Alright, so in those first 2 examples we use the distributive property, and another way to multiply binomials together is by using what's called the FOIL method. The letters of the word FOIL stand for first, outer, inner, and last. First refers to the first terms of each binomial. Outer refers to the two terms on the outside of the expression. Inner refers to the two terms on the inside of the expression. And last refers to the last terms of each binomial. Here's an example of what I mean when I say first, outer, inner, last. Let's say we wanted to multiply these two binomials together. Okay. Ultimately, what ends up happening is each term in this binomial ends up getting distributed to each term in this binomial. So 7x would end up getting distributed to both 3x and negative 5, just as negative 1 would be distributed to 3x and negative 5 as well. So each term in the first gets distributed to each term in the second. Alright? Well, the FOIL method comes from this. Remember, the F stands for first. So I take the first terms in each binomial, 7x and 3x, multiply them together, I get 21x squared. And then O, which stands for outer, I take the outer terms in the entire expression, and I get 7x times negative 5, which is negative 35x. And the inner, the I stands for inner, so I take the inner terms of the expression, I get negative 1 times 3x. And the last two terms in each binomial gives me the product negative 1 times negative 5, which is positive 5. You may ask, okay, why don't we just distribute and we get the exact same answer? Well, the FOIL method is just a way of making sure that you multiplied each term in the first binomial by each term in the second binomial, because in the end you should end up with a first product, outer product, inner product, and last product, or a total of 4 products or 4 terms. Okay, so once I simplify this expression by combining like terms, I get negative 35 minus 3, which is negative 38x. So the product of these two using the FOIL method would be 21x squared minus 38x plus 5. Remember to come prepared to class with answers to these reflect questions. Okay, so let me show you an example of how you'd multiply two binomials together using FOIL. Okay, so the first thing I want to do is take a look here at my two binomials. Okay, notice that according to FOIL, I'm going to take the first terms in each binomial and multiply them together. So I have 12x times 3x. So multiplying 12x times 3x, I get 36x squared. Okay, next comes the outer terms, so that would be 12x times 6, which is 72x. Okay, and then the inner terms, which are these two terms here, I'd have negative 5 times positive 3x, which is negative 15x. And the last terms in each binomial would be negative 5 times positive 6, which is negative 30. Once again, combining like terms, I get plus 72x minus 15x will give me plus 57x. So the product of these two binomials using the FOIL method is 36x squared plus 57x minus 30. Okay, one more example. Let's say I want to multiply this time. Notice I'm not dealing with binomials anymore. In fact, this one's a monomial, and I'm multiplying by a trinomial. Okay, so how would we take care of this? Well, you just use the distributive property. Distributive property will always work. Every single time it will work, whether you're multiplying a binomial times a binomial times a trinomial, monomial times a trinomial like you're doing in this case. It doesn't really matter, because what I end up doing is distributing this 4x squared inside to each of the terms inside the trinomial, and I would get 4x squared times this. So this is the result of multiplying each term in my trinomial by the monomial on the outside. Okay, which would result in this 4x squared being multiplied by each and every term. Okay, this next step here is just multiplying through and simplifying each of these terms. So notice my coefficient here would be 4 times 2, which is 8, and I have x squared times x to the power 3. From integer exponents property, you know that that's x to the power 5. And then we have 4 times negative 1 here. 4 times negative 1, that would be negative 4 x to the power 2 plus 2, which is 4, plus 5 times 4, which is 20, x squared. Alright, if I want to multiply these polynomials, notice here I'm multiplying a binomial by a trinomial. Pretty much exactly the same thing. Okay, here I can use a horizontal arrangement to distribute the x inside to each and every term inside the trinomial here. So I'd have x times negative x squared plus x times 2x plus x times 1, which is represented here. And then I have to distribute the negative 3 inside. So I'd have negative 3 times negative x squared, which is negative 3 times negative x squared here. Negative 3 times 2x plus negative 3 times 1, which gives me this resulting expression after distributing the each term in the binomial into each term in this trinomial. Okay. Notice that x times negative x squared is negative x to the power 3 plus 2x squared plus x, okay, plus 3x squared, because I have a negative times a negative 1, which is positive 3. So I have positive 3x squared minus 6x. I have negative 3 times 2, that's negative 6, minus 3. Okay. Notice I need to combine like terms because I have an x squared term here, x squared term here. Combining those two terms together, I get 5x squared. And notice I have more like terms in x and negative 6x, which would give me negative 5x. So this is the result of the multiplication after simplification as well. So the product of the binomial and the trinomial is this resulting polynomial with 4 terms. I could also multiply those same two polynomials using a vertical arrangement, just like you know how to do when you're multiplying two numbers together. Right? So if you're multiplying two numbers together, you basically put them one underneath each other, and then one underneath the other, rather. Okay, so what I'm going to do is I'm going to take my larger polynomial and put it on top, and the smaller one put it on the bottom. And just like you multiply numbers, I'm going to multiply this number by each and every term in the trinomial. So notice I'll get negative 3 times 1, which is negative 3, plus negative 3 times 2x, which is negative 6x, plus negative 3 times negative x squared, which is positive 3x squared. Okay, and I do the exact same thing with the x. I'm going to distribute or multiply x times each and every one of these terms in the trinomial. So I get x times 1, which is x, x times 2x, which is 2x squared, plus x times negative x squared, which is negative x to the power 3. And then you add, just like you would do if you were multiplying numbers together. Well, I have negative 3 plus 0, that's negative 3. Negative 6x plus x, that's negative 5x. And 3x squared plus 2x squared, that's 5x squared. I get the exact same result as when I use the horizontal arrangement. Okay, so it's up to you which one of these arrangements you prefer. This one is nice because it uses the fact that you already know how to multiply two numbers together. It's the same exact idea behind it. Alright, so the question that we answered is, how do you multiply polynomials together? Well, you can use the distributive property to multiply every term in the first factor by every term in the second factor. For two polynomials with m and n number of terms, the resulting product will have m times n terms before you simplify. Notice that whenever you multiply, for example, two binomials together, you're multiplying a polynomial with two terms and another polynomial with two terms. You end up with 4 terms. The first product, outer product, inner product, and last product. So the resulting product, you would have 2 times 2 terms, which is 4 terms. Okay, in order to summarize, make a table describing the methods for multiplying polynomials. There's a few ways we learned. Give examples for multiplying monomials, binomials, and trinomials.